we've got some information about us. We've been around for 10 years, offices in Philly, Chicago, and Austin. Backgrounds, everyone can look that stuff up, and you actually have 2 of 3 partners on the webinar today. So myself, Ron Schleck, and then also Brian Bailey, who will be speaking in a second here. We've talked previously about a couple different areas, one of them being some of the detection pitfalls that people have seen, and then also incident response. We're not going to rehash those issues, talk about why people have been having problems on the detection side, where we kind of touched on detecting the things that normally haven't been seen, so blind spots and what they're monitoring and how they're doing it, but then strictly relying on signature-based or old data points. Also talking about having too much data, not only just too much to monitor, just because we've all relied on information and information sources, and that stuff has grown dramatically over the past 5 to 10 years, but then also too much data when we're actually talking about alerts, just the volume of alerts that people have seen when they are doing monitoring appropriately. And then the third big tenet that we've always talked about with detection pitfalls has been staffing. The fact that nearly 66% of CISOs have said that they're understaffed, and then the confidence and ability, not necessarily that people don't know what they're doing, but they're spread very thin in the fact that they're being asked to not only take part in projects and be part of the actual business where security should be driven, but then also being appropriately staffed and actually having the capabilities to understand the alerts that come in. What we're talking a little bit more about today is the fact that we've seen a couple large breaches, going back even into 2014, 2013, 2014, things like Neiman Marcus and Target, where we've seen, looking at them now, there's been a great volume of alerts, but it's unfortunately taken companies, organizations, a lot longer to be able to find the right alerts and then also make the changes or track down exactly what's going on. In some cases it's been 3.5 months, some cases 6 months, and now we're at the point, just looking at statistics, that the average cost for an actual breach has risen over the past few years, from 2013 to 2016. We're looking about $158 per record, and the time and the amount of money and solutions, and then also engaging professional services firms, has dramatically helped that decrease, but the detection times have still been pretty high. So unfortunately, there's still been a lot of money sunk into the actual response, but in terms of bridging that gap and trying to bring down the time from detection to actual response and closing that down has been a real concern with folks. So with all that said, that's kind of the high-level background of the webinar. I'll turn it over to Brian Bailey, which will jump right into it.
All right, thanks, Ron. So I think one of the major points that we need to take away from this is understanding what the problem with logging, detection, alerting, response, all that stuff. Understand what the problem is, and then talking about what we can do to help you and to help any client really solve that problem. So when we talk about our managed service, which is BTB Security's Radar, stands for Rapid Advanced Detection and Response, we looked at this problem from a hacker's perspective. As Renee mentioned, the folks here at BTB Security, we've got pretty extensive security backgrounds. We're not jumping onto the security bandwagon late in the game. We've been doing this for 15 plus years each for the managing partners. So when we approached Radar as a managed service, we did so as individuals and practitioners in the security space that have done penetration testing. We know how to break into organizations. We know how to perform breaches. And when we looked at problems like this, we thought, well, how would we help our clients detect these events? How would we detect ourselves? How would we respond to incidents where we were the perpetrators? And our initial attempts at this was, when we did a penetration test, we would write a great report. We would come up with a summary of ways that they could enhance their detection capabilities. During the event itself, during the penetration test, we'd always ask our clients, well, are you seeing any kind of activity? What kind of alerts are being generated on your side? How is security operations, or in some cases IT operations, responding to the event? And time and again, it was something where we would not see something, or they would not see something until maybe the week after, or even 2 weeks after, or maybe not at all. We'd come up with a great way to help them enhance their detective capabilities through our assessment work. But unfortunately, we'd come back the very next year and it would be the same story. So the long and short of it is we said, well, if we were going to do it, how would we do it? And this is where Radar was born. It was initially built as a solution, right? Something that we saw the competitors in the space, we found them lacking and thought we could do better. And as we developed Radar as a solution, the solution being a SIM product that does a lot of enhanced alerting, enhanced correlation, we thought we had something good going. But when we thought about what the problem was, we looked back at some of our penetration tests, and we know that there's clients out there that have some of these solutions in place, some big names, and they would still struggle. We knew that they had alerting in place, but they still struggled. And we thought about why. Well, what's the root cause here? And it really isn't about so much the solution side of it. I think ours is better than any on the market today. I think we could box it up and ship it and have some good, happy customers. But we're not really solving the problem. That's what BTB security is all about. We don't want to be in this just for a piece of the pie. We want to make sure that we are actually making a difference, and that's where Radar as a solution turned into Radar as a service. Because you can take all of the solutions that are out there today. You can pick the best one. We think it's BTB Security's Radar, but ultimately, what you have to do when you receive an alert is do something with it. What is the action that needs to be taken when an alert is received? And this is where a lot of our clients kind of struggled to make gains. And ultimately, we decided that in order to best serve our client, we have to take this great solution, but we have to back it with humans. We have to back it with the capability to respond to these events and to provide expert guidance. So when we discuss how we do this, we've talked with clients in the past that have said, well, here are our critical systems. We need to make sure that these are monitored. And the reality of the situation is when you look at security, you have to look at everything. When we do any type of penetration testing, and I'm sure there are folks on the call today that have had penetration testing done, where the first breach isn't your database server, it isn't your Active Directory domain controller, it's a development server. Maybe it's an end user workstation. Penetration testing and hacking in general is really about finding that first chink in the armor. So when we talk about logging and we talk about meaningful security data, and when we talk about no blind spots, that's what we mean. We want to make sure that we collect every type of meaningful security data within your environment. And that sounds like a lofty goal, but I think it's one that is critical to the success of any type of managed service that does or offers detection and response capabilities. We don't want to be in a situation as a provider to maybe see something from a firewall's perspective, but then have no other data to go on to determine whether or not an actual event occurred. Because we see, a port scan, for example, on the firewall, what does that mean really? Is the attacker doing anything else? Do you need an alert that says there was a port scan? Where's the context? Where's the value? So when we built Radar, we wanted to make sure that we had logs and meaningful security data from anything that can produce it. And this goes from operating system events like Windows and Linux, firewall events. We also go down to the application layer. Some of our competitors do OS events and firewall events. We go into the application layer. So think web servers, Apache, IS, Tomcat. Think application servers. Well, I guess Tomcat falls into the application server side, WebLogic, things like that. We also go into databases as well. So Oracle, Microsoft SQL, it's not a problem. We have expert guidance to configure those systems to produce meaningful security data. We also offer, as part of Radar, network intrusion detection sensors that we maintain, and also endpoint events. So we leverage Carbon Black to monitor endpoints, and we have a lot of cool things built in around that. But from this perspective, we really get a full view, and we can typically recreate a security event based on these logs that we see. So one of the other key aspects to this that I want to make clear is that when it comes to log collection, we don't want to be in a position where we say, well, we don't support that. We don't want to be in a position where we say, well, we've not collected logs from that before, so I don't think that's going to be something that we can do for you. The way we've built Radar is we can very quickly build mappings. We can build things that pull in data from really any source, even if it's a custom application that you've developed internally that produces meaningful security data. We want to be able to work with you to collect that. So all of the data, essentially, you can really consider that just as long as you can ship that data to us, as long as you can get it to BTB Security's Radar appliance, we're good to go. We take care of the log collection. We do any kind of pre-processing on that event. So if there's any kind of maybe like malformed syslog, maybe there is some just some quick modifications of that data before we send it through our process, we'll do that. Field mapping is obviously a big one. So if you look at any SIM provider out there, they're going to have that capability. We have that capability, and we can do it across any data type that exists, right? So if you have JSON, XML, key value pairs, things that are well formed, we support that. If you have a mix and match, some vendors like to do that for some reason, we can support it. And then any kind of free-form log as well, we can handle that without issue. And then we go through our normalization process. Now this is the field mapping and normalization process go hand in hand, because what we do with Radar is we don't treat individual systems or individual platforms as special cases. We don't have a Cisco alert. We don't have a Microsoft alert. We have alerts that have been that are based on normalized sets of data. So if you think about firewalls, whether it's a Cisco, a Palo Alto, or Juniper, they all do the same thing. They have different feature sets, sure, but they're all based on governing traffic. So the normalization process that we employ essentially creates event classes for these different types of things. So we have firewall-related alerts instead of Cisco or Juniper. For things like, a simple example being brute force or login anomaly detection, we don't say, well, this is our plugin for Windows and this one is for Linux, and if there's an attacker that maybe crosses that boundary, there's no correlation. That's not the case. When we look at those, a login is a login, whether it's on an operating system, whether it's a VPN, an application, that's all normalized. So it allows us and really empowers us to create signatures, to create behavioral rules, to do different things like, we'll talk a little bit more about our virtual analysts and how they fit into the puzzle. But it allows us to be general and generic instead of vendor specific. But before we move on, I want to make sure and make it very clear that this is all on BTB Security. This is all part of the Radar service. If you have a certain set of logs that you want to transfer to us, we're not going to tell you, well, you have to make sure that you map them this way, that you have to do all of this work, you have to have your developers make all these changes, or we don't support it. That's not the case. We have the capability. It's on us. We know how to work with it. So just give us the logs, and we're good to go. So data collection for the sake of itself is irrelevant unless you do something with it. So this is where our alert flow and our alerting engine comes in. Now we've talked about the normalization of data so that we can create via our alert engine very generic, very general rules around different types of behavior that would indicate or could potentially indicate misuse or abuse in an environment. So our alert engine is really the first thing that goes back into our index, retrieves very large sets of data, parses through them, looking for patterns, looking for behaviors, and in some cases signatures, to determine whether or not a security event might be present. It takes that security event, wraps it up, and it sends it over to our correlations engine. Correlations are designed to take that event and do a machine's job of putting that into context. There are certain aspects that maybe it's maybe it's a web application type of attack where we see a significant number of 404s or 403 responses from the web server. That might indicate an attack. So a correlation might look at that and go, okay, do we see anything else from this source address that might be notable? Do we see anything, is there anything maybe about the user agent that is notable or interesting? We also look for things like we have the ability to classify sensitive usernames or sensitive hosts or applications, so that the correlation can look at that and say, hey, this particular attack is targeting maybe a VPN server, or it's targeting an application that people don't normally access, and it's usually just for a couple customers. It might be a little bit more sensitive, and that allows the alert correlations engine to bump up that score, so that when it gets when it starts to go through the process a little bit further, there are some different actions that we can take based on that score. So the next piece is our virtual analyst, what we call advanced correlations. This is designed to, at its very core, it's designed to simulate analyst behavior. So when there are certain events that come through that if a human were to review those every time, they would perform the same tasks every time. Because that could be heavily scripted, we can add some scripted intelligence to this particular virtual analyst to perform those actions. So that reduces a lot of the effort when it comes to analysis of this event. So the advanced correlations is an important piece. There are some aspects of it that allow us to make decisions in an automated fashion. There are some instances where the virtual analyst can just provide us with more information about the event. Think of things like, if there's a particular user that's involved with the event, we can go in there and say, okay, well, give us the user's normal workstation name. Where do we see them logging in normally from? We can get certain metrics like when was their password last changed? When is this event coming from potentially a shared resource? Do we see a lot of users leveraging this event or leveraging this source? Think of things like maybe a Citrix environment, or maybe it's an application that's behind a load balancer. So these are things that we can look at and we can add, so that by the time it gets to a human, we've already collected that information, and it really speeds up the process. The next piece is our virtual analyst that is involved with machine learning. This is the latest and greatest buzzword. If you're not aware of machine learning, unfortunately we have it too. But it's a great buzzword. But it certainly shouldn't be a mysterious black box aspect to it. Machine learning at its core is very cool, but it's really not as amazing as some folks make it out to be. Machine learning is about making sure that you can identify patterns in some automated way, and then coming to conclusion based on those patterns or those repetitive type of events. So we use machine learning in a couple different ways. We like to see, this is our primary source of anomaly detection. So when we see things that are strange in the environment, this is what empowers us to generate an alert that then a human analyzes and determines what the proper course of action is. Machine learning is, sometimes we have some instances where it's a little bit on the false positive side. We have others where it's very focused. Think of login type of anomalies. So if you have a user, any given user, they're going to leverage the same resources for the most part. When they start to leverage resources outside of that and they start to deviate from their normal behavior, maybe we see a login to a database server or a login attempt to a database server that they never touched before, right? It might be that their role has changed and they're now leveraging a new application, or it might be that this is an account that is potentially compromised. Maybe there's an attacker in the environment and they're pivoting through their system. Virtual analysts can also, or the machine learning side of this, can also look at web application behavior, right? What is normal for a web application? When a user starts accessing this, what does a normal session look like? What pages do they normally access? And when things deviate from that, we can generate alerts and intelligence around it. But you can take everything I've said thus far, and you can package all of it up. You can put, you can put it in a box. You can put a shiny logo on it and sell it as a solution, and sell support packages, And I think we would do well. I think we would do very well. It would be a very competitive product. I think it would be the best in the industry. But again, like I said before, that's not where folks are failing. Folks are failing quite often on the process side. When you receive an alert, what do you do with it? When you have a solution like this, what does it look like 6 months or a year after implementation? Who's been taking care of it? Who's been updating their rule set? Who's been pruning false positives? Who's been making sure that it's collecting all of the data that it should? That's where a big portion of the problem resides, and that's where the next piece of this, I think, is the most important. And this is what Radar really is. It is a service. It is powered by humans. It is powered by security experts that are staffed 24/7 by 365. Any type of alert that comes out of Radar, any type of intelligence that comes out of Radar, goes first and foremost to the BTB security SOC, so our Security Operations Center. This is where an analyst reviews alerts. They put them into context. So this isn't something where we see a port scan alert and go, oh, our client should really know about this port scan. It's very dangerous. We look at that and say, okay, well, what else did the attacker do? Does this look automated? Was it very short-lived? Does it appear to be targeted? Does there appear to be some type of intent behind it, or is it background internet noise? Same from from a web application or really any public-facing service that's out there. Does it look like noise? Does it look like something that maybe is targeted? What else are they doing? So the Security Operations Center is really designed to take an event, put it into context, and what they do from there is if a threat is identified or a legitimate threat is identified, then we start working with our clients, with their security operations team if they have one, or their IT operations team if that's what they have. The alerts, the notifications that come out of the SOC are always, without exception, actionable. There is never going to be an alert that comes out that says, hey, something strange happened. Good luck with it. We just wanted you to know that this happened. There's going to be an action associated with it. It's going to be, something on the major side like, hey, there's a malicious actor in the environment. Here's the systems that are compromised. We recommend that you take this system offline. We recommend that you block this IP address. We recommend that you disable this user account. Additionally, that's not where it ends, right? If we see something serious like a malicious actor in the environment, we don't look at that and say, okay, well, here's your recommendations. Good luck. You have something serious on your hands. We start working with you then. Typically, we're on the phone. We're on conference calls. We've got all the team members involved, and we start, doing some very specific incident response for the issue. That's at its most serious. We also have alerts that might be a little bit lower on the totem pole when it comes to priority, things like, there's maybe you have potentially unwanted applications in your environment. We do our very best to provide you with specific recommendations, how to remove them, and then we also do root cause analyses for most of our events to determine what the root cause was. And this allows our clients to make obviously tactical choices on how to remediate these issues quickly, but then they can turn these into strategic options. Why are we suddenly, beleaguered with potentially unwanted applications? What security control of ours is failing? And we can certainly produce some metrics around that will provide some guidance that will allow the formation of those strategic decisions. So again, you can take everything, throw it in the garbage. What you should come away with this is the human side of it, the service side of it. You have security experts 24/7, and this is how we get from breach, from detection of event to normal very quickly. We'll go into a couple very technical examples here, but if you look at ransomware, ransomware is I think the biggest name on the board right now in terms of threats. We have clients that are they're incident response clients, but they're not Radar clients, and they come to us and say, hey, we've got ransomware, we're not sure what to do, and obviously we'll do our best to provide as much guidance as we can. But detection and cleanup of that is very difficult, because if you don't catch a ransomware quickly, its job is to be fast, and it's very good at its job. So you need to make sure that you have some detective capabilities in there that can respond very quickly. So enough PowerPoint. Let's do some technical demo, and I can show you what this means. So this is BTB Security's Radar portal. When we talk about all of the data that comes into Radar, we talk about all of our normalization and all this stuff. That's fine and that's good. But we need to make sure that the data is accessible and it's accessible very quickly. Before we go any further, I do want to make it very clear that any Radar client that we have, Radar is not a black box. It's not just some mystery service that just works in the background and you really hope that it works well. All of the dashboards that I'm going to showcase today is fully accessible by all of our clients. So these are the same dashboards that we use in the Security Operations Center to review alerts, to put them in context. These are available to you as well. We're also all about flexibility with your data. So if you're looking at this and saying, hey, it would be really cool if we had maybe a dashboard that did this, that presented data in this way. Maybe it's for a security operations need or maybe it's for an IT operations need. The data is there. We use it for security purposes. Maybe you have some different use cases for it as well. So this is our just kind of our stock-based list of dashboards. It showcases some of the applications that we support. Obviously, like I said earlier, we can support any application and we can create dashboards around it. It's pretty easy for us to do that. So you have things on the Windows side. We have very specific views into things like user modifications, group modifications, login failures. We look at firewall data, network data, proxy data, and then web server logs as well, just to illustrate some of the things that we can do. So this is our firewall dashboard, and this is a great dashboard to start with because it allows us to really identify a lot of the functionality around working with this data. So first and foremost, we have our time picker up top. It's all relative to right now. So you can look at the past 5 minutes, past hour, 24 hours, all the way up to 30 days. We also have our queries up here. This kind of showcases some of the normalization that we've talked about before. Again, this is a firewall dashboard. It's not an ASA dashboard or a Palo Alto dashboard. This gives you a nice single pane of glass into all of the firewall activity in your environment. And in this case, we're just focusing on our event classes of ACL permit and ACL deny. So what's being allowed and what's being denied by the firewall. And then we have our filters here. This is what we use to constrain the data, and we'll go over this in a little bit. But first and foremost, we have a time-based histogram. Works very well for visualization of data. The panels here are all interactive, so you can just click and highlight this. And once you let go of your mouse button, it will dial into that specific time. All of the panels then change. You can see that a new filter was created, and now we have a very specific view. So if we're looking at this spike and we want to get a little bit more detail, we can go down to some of the bar charts here and we can start interacting with these and saying, okay, well the top source here is this IP address. Let's go ahead and click on that. And now the view is constrained once again to just this source IP address. Right, and this allows us to, we'll go over some of the GeoIP stuff here in a second, but this allows us to take a large set of data, interact from a panel perspective, and really kind of focus and get access to that data very quickly. I'm going to go ahead and get rid of those filters real quick, and we're going to go back to our default view. And I do want to showcase some of the geospatial data that we have available. Depending on your organization, GeoIP data might be very useful. So if you have, let's say, an organization that is really just national, or maybe there are just specific regions in the country that you operate in, a connection from Brazil or Russia or China, that might be very anomalous for your environment. Now on the machine learning side, we can pick that up. But signatures are typically faster, right? So if you have that in your environment where maybe a VPN connection from China is something that is very scary, it's easy for us to create a signature for that and generate some alerts and some intelligence around it. These are all interactive as well. So if you go over here and you click on China, you can see that there are 261 events being sourced from China. And if we scroll up top here, you can see that a filter was created for source country China. And now our view changes once again, and we can get access to some cool data that way. One thing to note about these dashboards is you saw some of the fields like source IP, source country. You don't technically have to enter those. You don't technically have to work with the panels. You can just click the Add Query filter here, and instead of star, we can just put in an IP address. Not necessarily destination, not necessarily source, really just a string. Here is a term, 10.180.40.128. And you can see now our view is constrained based on that. It's not any specific source or destination, like I said, but it allows us to just say, hey, I've got this term, I've got this indicator of compromise. Let me just throw it into the dashboard here and see what kind of view we get. Now, charts are great. Visualization is important, but we need the raw data. We need the actual contents. So in this case, we have a view, a table, into the firewall data that gives us everything by the event time. Everything is based on UTC. We have the host name where this particular event is sourced from, so the actual firewall, and then some other metrics that are interesting about firewall traffic, source, destination, information, as well as protocol. And you can also click on these and get the full list of fields that have been mapped out. All of these you can interact with them as well. You can say do not include this particular term in our result set, or you can include it. You can also do microanalyses of this data, and you can just very quickly click here and include it or remove it from the view. Over on the left-hand side, if you want to say give me the most event IDs in this view, you can very quickly see that as well. So the takeaway here is access to this data is very fast. We don't want to be in a position where we collect all this data, but we have to wait 2 hours for a report to come out. That's going to kill anyone's ability to respond to a security event. Access needs to be fast. This scales out as well into the millions of events per day. So right now this is a lab environment. What you're looking at is a demo, right? So most things are going to be staged. We're dealing with maybe a lower document count. But we have clients that range from small side, so maybe just a few million events per day, all the way up to very large clients where we're talking about 60 to 100 million events per day. So that's the firewall dashboard. We also, like I said earlier, have intrusion detection built in. We leverage Cisco's Snort. We have professional threat feeds from Snort, the subscriber VRT feed. We have Proof Points Emerging Threats Professional feed, and we also have the BTB Security Radar feed. So really, if another client is affected by something and we want to create a specific rule, all of our clients essentially get the benefit of activity within the radar network. So when it comes to network IDS, we definitely want to work with our clients, determine where the proper placement of sensors should be. We definitely want to see all egress traffic from the environment, so DMZs out, internal networks out to the internet. That's very important, but maybe there are specific segments in your environment where additional scrutiny should be made. Think PCI environments, or maybe some very specific server segments where an IDS sensor would be required. We also have web server logs. It's a demo environment. Things are staged. This doesn't look very interesting, but we can go down here and we can see what kind of events that we can get. So again, this is IIS, Apache, Nginx. Web server logs, or access logs in particular, are typically the same. We do and can provide some guidance on enhancing default logging to give us more fields than the default. Think things like exported for headers, cookies refer, all that good stuff. All of this is available in these views. We have the full raw message included as well. So if you wanted to see what this looked for, or if you're used to looking at this, we have that capability. And then of course we have our Windows environment. Windows is obviously a critical component to monitor. So anything, if you want to sort by event ID, by a particular user or particular host, that's all easy to do. If you go down here and actually have a look at the event itself, we again pull in the full message. So if you're used to looking at event logs in their kind of friendly form that Microsoft provides, we have that as well. It's important to note that all of this is indexed as well. And all of this is full text search capable. So if we don't map a particular field out of the Windows events, it doesn't mean that you can't search for it. You can take an ID like this CoreNet IPS, IP HTTPS in, copy that, and just, as an example, put that in quotes. And now we have a very specific view for any event that contains that term. So everything's full text searchable. It's super easy to use. Everything's very intuitive. And that's really kind of what we wanted to showcase today, is not only the speed, but our capabilities, and that this data is all highly accessible. We are also very flexible. So again, like I said earlier, if you have any specific views or any alterations that you want, we have that capability. So this is the SIM side of Radar, right? This is the ability to access data quickly. So let's talk about alerts, right? Accessing or collecting logs for the sake of themselves is nice. It's a nice to have, but unless you do something with it, it becomes pointless. So our ticketing system that we use is not something that is easily shared via a demo. There's a lot of information in there that might, that contains client information. So, and it's not easy to obfuscate or clean. So as part of this demo, what we wanted to showcase is some of the export capability. So if you wanted to, at any point, view raw alerts from Radar, we do have that capability. It's not something we typically share because that's a lot of noise, but there are some clients that want it. So what I'm going to show and illustrate today with some of the alerting is some of those email exports that we can provide. So the first one is probably our most basic alert, and this is probably something that really any kind of service provider that does security monitoring should be able to do. But this does showcase some of the different aspects that we have. So this is a brute force alert, but it's not as dumb as a typical brute force alert, right? It's still a brute force alert, but it has some interesting aspects to it. So when a brute force comes in, Radar is able to identify that. And like I said previously, it goes through our correlations engine and it goes through our virtual analyst as well before it even reaches the Security Operations Center. So you'll see the first line here is the Radar alert, and this is not a brute force. It's called a brute force excessive targets greater than 5 based on the usernames, and it also has the propagator as well, or the source of the event, the IP address in this case. We have some descriptions of score, right? Score tells our analysts what Radar thinks the likelihood of this event being legitimate is. Obviously, a score of 0 is, take that with a grain of salt. A score of 150 is certainly on the high side. Priority 1, we have SLAs for any priority 1 alert that comes into Radar. A human analyst will be looking at that event and analyzing it within 5 minutes of Radar detecting it. In this case, we have when the activity was first and last seen. As you can see here, this activity took place in less than a second. And we also have our duration indicator. So duration is important to know because this is the window in which Radar saw this event occurring. It saw it within a 6-minute window. And when it comes to durations, Radar looks at events going back, the past 5 or 6 minutes, goes past 30 minutes, 60 minutes, 120, 3 hours, and it rolls, and that's a rolling window, all the way up to 24 hours. And that's just on the automated side. That allows us to generate events for very fast attacks like this, or also for very slow running attacks, kind of the low and slow attacks that typically try to fly under the radar, if you'll permit the horrible pun. So that, this is an automated alert that comes in, the Security Operations Center looks at it. We see the IP address, we see the host that it's targeting, we see how many times the attempt has been made, we see the different usernames that are being targeted by this. This is where the excessive users correlation comes in. Typically, if it's just one source IP address targeting one system using one username, that becomes a different looking brute force event that we'll talk about in a second. You can see that some of the correlations were matched here that we just discussed. And here are some details from the virtual analyst report. Now in this case, the virtual analyst did not make a decision itself. It did decide to provide some additional information about the event. So you can see things like the normal workstation handler, the did password change handler, and the shared resource handler that I talked about earlier. And this is just designed to provide our analysts with, something they would look up anyway. We can automate that. We can provide that as a report. And then we have our watch list. Watch list is, if you think back to some of the dashboards that I showed you, the watch list is a combination of all of those, right? So there are, numerous occasions where you want to see, take a term like a username or an IP address and say, show me everywhere, every document that's been collected by Radar, show me where this appears. It's a great tool, and that certainly is available as well for our clients. So that's an alert. If we want to have a look at where this what this looks like in the dashboards, we can certainly head over to the Windows login failures, and this is just for illustration purposes. Typically, when it comes to responding to this event, we're going to want to identify what that source is, where it's coming from. This is clearly an event. This isn't something that's probably a false positive. This is something where we would be on the phone with you saying, we see some anomalous activity. Here's all the details we have. Here's our recommendations for it, and we're going to keep an eye on this IP address while the security operations team starts to remediate. So again, we can just put in the IP address here. We get no results. So let's go ahead and go back and say, okay, well, when did this actually occur? It occurred on the 21st. Obviously, we're going to respond to that a lot quicker. This is a demo environment, so some of these attacks were staged. So we can go up here to our time picker, and we can just very quickly say, okay, give me everything from the 20th to the 22nd. That should encompass what we're looking for. And now we get some good results. We can see the 4625 and the 407076 events that indicate failures. We see the target username in these cases are user 1, super user, R. Gravel, who's one of our analysts, Jay Wilson, another one, and David Reich. These are, when we see this type of event, we say, okay, it's not just looking for generic user accounts. It's looking for user accounts that actually exist. That kind of, from a human side, a security expert side, we could say they have some additional information. This might be a little bit more serious than, some automated activity. So we also have a, we alluded to the low and slow type of attack. In this case, it's another brute force, but this is excessive targets from a single source. This is a source address targeting a Linux system. They're only touching their root account, and they did it 22 times in the span of about 20 minutes. All right, so this is something, just wanted to showcase our capability to identify events that are a little bit longer running and a little bit slower. So next up on the list is web server detection, web server alerting. So this is our signature-based alerts. Now, signatures for a long time now have kind of been poo-pooed by the security industry. I don't think the operations folks poo-poo them. I think they understand the value of them. But I think in terms of folks that might be interested in blogging as the main career, they kind of give them the thumbs down. Signatures, don't believe them. Signatures are still very valid today. Signatures are very fast. There are many instances where we see live malicious actors in the environment. They forget to change the user agent on their attack tools. They forget to maybe even disable some of their auto-updating on some of their systems, so we see those call homes. These are things we can build signatures around that are looking for very specific things. They're great indicators of compromise, and they're very, very quick. In this particular case, we have an alert that looks for known malicious user agents in web server logs. It's not the most interesting. It's not the most elegant. It's a laundry list of user agents that we see on a regular basis attacking our clients, that we use during penetration tests. We throw them in there because if an attacker trips one of these, we're on them very, very quickly. So in this case, in the alert that comes through, we have the URIs that were targeted. We have the queries that are targeted, And of course, we have the user agent. In this case, it is dirbuster. Dirbuster is, if you're not familiar, it's a way for an attacker to look for content that might not be otherwise discoverable on a web application. We also look on the behavior side for web application attacks, so things that aren't necessarily signature-oriented, but these are things that are definitely strange, either strange specific to the application or just strange in general. In this case, this is a more general alert where we see a number of 500 events. If you're familiar with web application attacks, there's a lot of different types of attack vectors that leverage either fuzzing an application to see how it responds to certain type of input. SQL injection or the discovery of SQL injection in many cases will generate a lot of 500 alerts. Unfortunately, there's really bad applications that are built that just have a lot of errors that come out of them. This is just one of those showcases that when we see these things, it's not always an attack. It goes to our Security Operations Center. We look at it, and we put some human intuition into it. But in this particular case, again, this happened on the 21st. So we can go over here to our web server logs, go ahead and go back to that particular date. And we can see in our nice pristine demo environment that where everything is staged, it's very clear to see on the time-based histogram where these particular events happened. Now, in reality, on the web application side, you're not going to have a very smooth graph like this. You're going to have stuff that's all over the place. But this just kind of showcases what we can do to jump into a dashboard. We can highlight this particular area, look at this particular orange bump here, and we can very quickly go down and see what kind of activity is taking place. So in this case, the test.php URI is, the attacker in this case is just incrementally going through the parameter values, integers, increasing by 1 each time. This is a very common attack when you're looking for web application flaws. So other things that we can do that are very interesting, we can look for anomalous administrator activity. So in this case, we're going to leverage Carbon Black, and we are going to leverage a behavioral rule that we put in place that looks for the invocation of the net command under certain contexts. So in this case, we can see that the process name was net, we see when it was executed, and we see the command that was actually run. So in this case, we see via command line a user being added to the domain admins group. This is not something that you'll typically see. So we want to make sure that we alert on that and then go ahead and have a look at it and put it into context. So this is the Carbon Black interface. Carbon Black provides a very cool process tree that allows you to kind of walk down or walk through a process tree so you can see where it started. You can see other children processes that were spawned from it. And in this case, we're looking at the netgroup domain admins domain command. So this in and of itself isn't particularly strange, but if we go back here to cmd.exe, we can see maybe what other things it's trying to do, and put that into context and say, okay, well, is this something an administrator would do? Is it something that an attacker would do? And again, we can take some human intuition and our security expertise to make that determination. In this case, we also see some fsutil commands that are doing something kind of anomalous here. So in this case, we can call this an event. We can start working through it and identifying root cause, looking for how we can provide guidance, etc. So another one that I wanted to kind of talk through is PowerShell misuse. PowerShell is a great IT operations utility, allows you to do a lot of cool scripting. Attackers are leveraging that quite often to do a whole lot of different interesting things. There are entire attack suites like Empire that are built around leveraging PowerShell to do some very, very cool or very scary, depending on your vantage point, tasks within a compromised environment. It's a great post-exploitation tool. So if we look down at this, we can see again the command line. In this case, we have PowerShell being invoked with the bypass flag, so it's bypassing user access control. And we can head into radar again to very quickly get a look at the process tree and see what else this thing is doing. This long string here, you can see the ZM9Y, LC9, that stuff is base 64, and we can decode that to actually get access to the raw command that's being invoked by PowerShell. If we scroll down here, we can actually see some very interesting things about the process itself. We can see what files it's touching, we can see what DLLs are being loaded, and this in and of itself allows us to gain some insight into what PowerShell is doing. Certainly decoding that base 64 is the first step, but then we can start to see other interesting things about it. And we can walk back down the process tree. We can see command.exe. We can see command.exe being invoked from Internet Explorer, something that should never happen, something that is very scary. So that's something that, obviously we'd be jumping in on this. We'd be getting the security operations folks involved. Ransomware is another big one. We have our known bad egress alert. We have a lot of different ways to capture ransomware. One of them is the known bad egress alert. This is based on our professional security feeds that come in, people that are out there tracking Locky, tracking Zepto, and if we see these kind of events, we can really leverage our IDS to give us a very, very quick, a very quick response to this. So this is our network IDS known bad dashboard. These are things where we know that if we see this is drop what you're doing. These are priority ones. These are events that are very scary. This is a lab environment. We detonate all sorts of malware in here, so we typically get some good alerts. But in this case, we're going to focus on this Locky event, this Locky check-in. And what we can do here is we can actually take the source IP address, and we can leverage Carbon Black and say, okay, let's go into a process search. Take this IP address and essentially say, we know this event happened. Give me the process that reached out to this IP address. And in this case, we have obviously a generated name. We can click on this, and we can see, we can take an IDS alert and tie it, something that's a network-based alert, and we can tie that to the specific system, the user, and the actual process that is responsible for it. If we scroll down here and we look at some of the activity around this process and what it's doing, we can see the infamous instructions file and then the Zepto extensions, which are obviously things being encrypted. So that's an IDS alert that we leverage. We also have interesting behavior around ransomware, so things like command.exe launching from Internet Explorer, process or binary creation from Word documents, or things like WScript or CScript launching an unsigned binary. These are all behaviors of ransomware that we can catch. So in addition, we have one of our final tiers of detection capability. This is really just an anomaly check for any instance where a user is generating a lot of file writes. So in this particular case, we have the administrator account triggering our rapid file access alert, where they are touching, just under 20,000 different objects in a 3-minute time span, and we can see very quickly that these are, crypto related. This is a staged demo event, but this allows us and empowers us to have a number of different detective measures. Ransomware, as I'm sure everyone on the call is well aware, changes every day, and we are running into instances time and time again where behavior changes, payloads change. We want to make sure that we have enough hurdles in front of ransomware so that it trips over something. And as soon as it trips over one of those things, we can jump on it. We also have, as part of Radar, active response capabilities. Active response allows us to do some very interesting things. So if we look at this particular host, we can do what we call go live, which allows us to go into that host, pull log or pull actual binaries out of there. We also have the ability to isolate the host. So if we know that this host has been compromised, we can isolate it. Active response also empowers us to go in there and make some very, very fast remedial actions like blocking source IP addresses on the firewall, disabling user accounts, changing passwords. Again, isolating hosts is one of those things as well. So that's a very quick overview of the Radar service. Again, it's designed to collect as much meaningful security data as possible, and we're all about flexibility. We can create specific views into these things, into this data. We can create specific alerts based on unique applications in your environment. And then we also have the capability to detect anomalies based on things like machine learning. And this is all powered by the humans in the BTB Security Operations Center. So none of the events that you see, none of the interactions from the Radar service is going to be some automated spew of alerts that you're going to have to weed through every day. We take care of all of the maintenance of our IDS. We take care of all the maintenance of baseline in your environment. We help with deployment. Really, I think the Radar service solves the problem of detection and response capabilities in the security industry today. So that's my demo on this. Hopefully you found it informative. Let's maybe go ahead and open it up to some questions. So Renee, should they go ahead and just type in their questions in the chat window, and we can provide answers and feedback as appropriate?
That is right. That is correct. I see someone's actually typing in right now. Just type your questions in, and then Brian will address them. All right. Well, if no one has any questions, we'll end the webinar right now. Thank you so much for your attendance. Have a great day.
All right. Thanks, everyone. Take care.